Hi everyone, welcome to Chem Vibes with AJ, and today we're going to learn about organic chemistry. So, as the outline shows, what is organic chemistry, organic versus inorganic, and some examples for us to be able to differentiate between these two compounds. So, organic chemistry is a branch of chemistry that focuses on the study of compounds that contain carbon atoms. So, carbon is a unique element that can form diverse and complex molecules, making organic chemistry a very crucial field in understanding the chemistry of life. So, the main focus is on molecules that contain carbon and hydrogen bonds. So these molecules can range from simple structures to highly complex ones found in living organisms. Now, on the emphasis, carbon-carbon bonds, functional groups, and their reactions are key areas of emphasis in organic chemistry. So carbon-carbon bond play a very fundamental role in forming the backbone of organic molecule. Now the functional groups are specific arrangement of atoms within a molecule that determines its chemical behavior. So understanding how these functional groups react and interact with each other is very essential in organic chemistry. So let's take some examples. So we have organic compounds. Organic compounds come in various forms and have diverse applications. So the common ones is hydrocarbons like methane, ethane, which are composed of carbon and hydrogen atoms only. We have alcohols such as ethanol. They contain hydroxyl group. We have the aldehydes and ketones, which have the carboxyl carbonyl group. Carbonyl group. We have the carboxylic acid, such as acetic acid, that have a carboxyl group. So these are basically what we'll be looking at. Now, organic compound is a chemical compound that contains carbon atoms bonded to hydrogen atoms, as well as other elements like oxygen, nitrogen, sulfur, halogen, or phosphorus. So this means that organic compounds have the ability or have the capability to bind with other varieties of elements, including the carbon and hydrogen bonds. Now, the principal element in organic compound is carbon, because carbon is unique. Its uniqueness comes from the ability to form four bonds with other atoms. So this this word so this versatility allows carbon to create a wide range of complex and diverse molecules, making it the backbone of organic chemistry. Okay, so now let's compare organic and inorganic compounds. So on the parameters that we are doing our comparison, the first that we are going to talk about is the melting point and the boiling point. So for organic compounds, they generally have a low melting point and boiling point because they are held together by weak in the molecular forces like van der Waals forces or hydrogen forces. So the bond that is between them is very weak. So these forces are not strong as the ionic bonds found in organic compounds. So it makes the melting point and boiling point of organic compounds generally weak as compared to that of the inorganic compounds. So in contrast, for the inorganic compound, they have ionic bond that I said earlier on, which are stronger than the intramolecular forces such as the hydrogen. So as a result, they require more energy to break the bonds, leading to higher melting point and boiling point of inorganic compound. So for you to be able to break down the bonds that exist between inorganic compound, you need a very high amount of energy to do that compared to that of the organic, simply because for the inorganic, the bond that exists, it's very strong, and for the organic, the intermolecular or the hydrogen bonds, or the bonds that exist between these compounds, are very weak, hence requires a lesser temperature or less or lower boiling point. Now let's look at their solubility. So for organic compounds, most compounds are non-polar, meaning they do not readily dissolve in water, but there are exceptions like alcohol, carboxylic, which can form hydrogen bonds with water molecule, making them water soluble. You need to note that one. So for the inorganic compounds, on the other hand, many inorganic compounds are water soluble. They can easily dissolve in water. This is because the ionic or the polar covalent bond that exists in inorganic compounds can react with water molecules, allowing them to dissolve easily. So that is why with solubility, the inorganic compounds are water soluble. Yeah. Okay, so for the structure too, we all know that organic compounds are carbon-carbon and carbon-hydrogen bonds, and for the inorganic compounds, on the other hand, rarely contains what carbon and hydrogen bonds. With respect to the bond type, organic electrons are shared between atoms for the organic, but with the inorganic, they rarely contain carbon hydrogen bonds, and often have ionic bonds where electrons are transferred between them. So that's examples of organic compounds. We have the methane, we have the ethanol, we have glucose, we have acetic acid, we have aspirin, fat and oils, DNA, proteins as well. And with that of the inorganic compounds, we have the sodium chloride, carbon dioxide, ammonia, water, carbon monoxide. So we need to note some of the examples of organic and inorganic compounds. That is where we end today, and I hope you enjoyed the class. It's Chem Vibes with AJ.